So looking at worksheet 1, worksheet 1 on functions defined by integrals, the last one. Let's see if I have room to do all of this. So a of 2 would be the integral from 0 to 2 squared of 4 minus 2t dt. So you can see it. So that would be the integral from 0 to 4 of 4 minus 2t dt. I think there's two ways to work this one. If you're thinking area under this curve, 4 minus 2t is not the worst thing in the world to graph and do the area that way. If you're thinking antiderivative, that's how I'm going to do it, because that's how we usually end up doing these. So I'm going to take the antiderivative and plug in 4 and plug in 0. But again, area under curve for that one would work, because you can graph that and it would be geometry. So 4t minus t squared from 0 to 4. Antiderivative of 4 is 4t. Antiderivative of 2t would be t squared. So I plug in 4. 16 minus 16. Minus, plug in 0. 0 minus 0. Well, that's kind of nice. All of that to get 0. So a of 2 is equal to 0. A of 4, I can kind of jump in at this spot because it's the same antiderivative. It's just now going from 0 to, oh, be careful. What am I going to here? What's the upper limit going to be? 16. 0 to t squared, so 0 to 16. So 4 times 16 is 64. 16 squared is 256. And then 0 on the bottom end. And 64 minus 256 is, of course, negative 192. Right, a prime. Well, a of x is the integral from 0 to x squared, 4 minus 2t dt. But part B, I want a prime, so I want the derivative of a. The derivative of both sides. And this is where we start using the fundamental theorem of calculus. Derivative of a is a prime. But the derivative of the integral cancels each other out. And all I need to do is put x squared in for t. And then don't forget the chain rule times 2x. So now I'm ready to answer question B. A prime of 2 is just plug 2 in. So whatever we get when we plug 2 in. 4 minus 8 is negative 4, times 4 is negative 16. And a prime of 4, plug 4 in. And that's going to be, actually, that's going to be a safe stop. Why bother with the calculator? That's my answer. If you want a numerical answer that's cleaner looking than that, you're welcome to use a calculator and get one. What was it? Negative 224. But you wouldn't have to go that far. You could stop right there and be okay. Part C, the second derivative. If I take a derivative right now, I have to use the product rule. I could get around that by just distributing that 2x to everybody. So 8x minus 4x cubed. So A prime is 8x minus 4x cubed. So if I take a derivative of that, I get 8 minus 12x squared. This is for part C, because I need a second derivative. So the second derivative at 2 is 8 minus 12 times 2 squared. And be done. The second derivative at 4, 8 minus 12 times 4 squared. And again, I'm not messing with the calculator. We're good with that. Questions on that one or on other ones from that worksheet? Number 5. Yes, we can do number 5.